Tesla Optimus could be described as running like a marathon athlete, especially when compared to Russian robots we have seen sliding, stumbling, and crashing the ground just from attempting basic steps. In only a few months, Optimus evolved from wobbling like an elderly person struggling with balance into a humanoid robot capable of running at nearly 7 miles per hour, a speed that would have seemed impossible just a year ago. When you watch its stride, rhythm, foot placement, and especially the moment both feet leave the ground, the motion feels uncannily human. However, the real question is not whether Optimus can run faster or more realistically than other robots, but how this capability actually benefits everyday human life. Compared to robots from a decade ago, today's progress is astonishing, yet durability, efficiency, and reliability matter far more than flashy movement. A robot's true priority is not mimicking humans, but performing useful tasks with minimal energy consumption and maximum stability. The best robot is not the one that looks the most human, but the one that cleans a house efficiently, washes dishes properly, and operates safely for long periods. Many demonstrations of robots kicking, flipping, spinning, and running make people uneasy, especially when proportions look unnatural or centers of gravity are artificially lowered to improve performance. These design tricks may help in a lab, but they often prevent real-world deployment. Even if a robot is priced at $20,000, speed alone means nothing if the robot cannot be trusted inside a home. Concerns about privacy, surveillance, data collection, and potential misuse are legitimate, and this is where Tesla's emphasis on security and control becomes important. Elon Musk has stated that Optimus Gen 3 will be sold for around $20,000, and Tesla's ability to manufacture nearly every component in-house using gigapress technology gives credibility to that claim. Unlike competitors dependent on third-party suppliers, Tesla can scale faster and reduce costs aggressively. Optimus is designed not as a factory gimmick, but as a permanent household assistant, folding laundry, washing dishes, organizing items, assisting with cooking, carrying heavy objects, monitoring elderly family members, and triggering emergency alerts are central to Tesla's vision. At that point, Optimus is no longer just a robot, but a learning system that adapts to household habits and improves daily. This is the moment when science fiction begins to merge with reality. If smartphones extended the human mind, Optimus represents an extension of human hands and feet. One overlooked but critical milestone is Optimus' completed charging system. A fixed, standardized charging port signals readiness for 24/7 operation at scale. Reliable charging without human intervention is essential for deploying millions of robots. Tesla's attention to such details shows it has moved beyond research into preparation for mass production. The development timeline is unprecedented. 2022 showed a tethered, unstable prototype. 2023 brought basic walking and object handling. 2024 introduced balance and dexterity. 2025 demonstrated near-human running and advanced hands. No other hardware field has progressed this quickly. If this pace continues, robots capable of autonomous household management and long factory shifts are inevitable. Hands are the true breakthrough. Optimus' 22 degree of freedom hands enable delicate manipulation, from folding clothes to holding fragile objects. This level of dexterity allows tasks once impossible for robots, including playing the piano. Fine motor control, independent finger movement, and precise force feedback make such actions achievable. A robot that can handle paper without tearing it and hold an egg without breaking it is ready for real work. Tesla trains its systems using massive human motion datasets, teaching robots not just positions but applied force and adaptive movement. Gen 3 is optimized for mass production, mirroring the Model 3 strategy but on a far larger scale. Tesla is building an entirely new industry. As top engineers leave companies like Apple to join the Optimus team, it signals confidence in this future. Optimus is not a demo or experiment, but the foundation of a new era, one that may reshape labor, households, and society faster than anyone expects as Optimus moves closer to large-scale deployment. The implications extend far beyond convenience and productivity. A humanoid robot capable of performing household tasks autonomously introduces profound economic and social changes that humanity has never experienced before. For the first time, physical labor can be automated at scale in unstructured environments like homes, not just factories. This means time, the most valuable resource humans possess, can be reclaimed. Hours once spent cleaning, cooking, lifting, organizing, or caring for aging relatives could be redirected toward creativity, education, relationships, or rest. At the same time, this transition raises serious questions about employment, responsibility, and dependency. If robots handle basic labor, societies must adapt their economic models, retraining systems, and social safety nets. Tesla appears aware of this shift, positioning Optimus not as a replacement for humans, but as an assistant that amplifies human capability. The robot's ability to learn household routines, adapt to preferences, and operate safely around people is critical. Trust will determine adoption. That trust will be built through transparency, strict safety constraints, offline operation options, and clear user control. Musk has repeatedly emphasized that Optimus is designed to be slow, weak, and non-threatening around humans by default, prioritizing safety over raw power. This philosophy separates Optimus from fear-driven narratives often portrayed in media. The real revolution is not that a robot can run at 7 miles per hour, but that it can operate quietly in the background, solving mundane problems without constant supervision. When millions of households experience this shift, expectations of daily life will change permanently. Children will grow up seeing robots as helpers, not machines. Elderly individuals will gain independence and safety. Small businesses will access affordable automation, once reserved for large corporations. Just as smartphones reshape communication, work, and culture in ways no one fully predicted, humanoid robots will reshape physical interaction with the world. Optimus represents the first credible step toward that future, not because of spectacle, but because of scale, cost, and purpose. If Tesla succeeds, the question will no longer be whether robots belong in homes, but how humanity chooses to coexist with them, govern their use, and ensure their benefits are shared broadly rather than concentrated. That choice will define the next era of civilization. Ultimately, the success of Optimus will depend not on how impressive it looks in demonstrations, but on how invisible it becomes in daily life. The most transformative technologies are those that fade into the background while quietly improving human well-being. If Optimus reaches that point, it will not feel like a machine at all, but a natural extension of modern living to end that future. Productivity will no longer be limited by human exhaustion, and daily life will shift toward choice rather than obligation. What matters most is not speed or strength, but trust, usefulness, and the freedom such technology can ultimately provide. Subscribe to Drive Tech Tesla for more content.